Alright, before we start, as usual, please watch these videos first. And if you're done, let's get into it. We recall the concept of E-vector field or electric field, which if we have single particle with charge, then we have the electric vector field as this, which depend on position, and this case is for rest charge particle, which here, this system satisfies these two equations, and by Helmholtz theorem, we have this equation too, which in future video, it can be time dependent. Which now, the question is, how if electric field, or to be exact, what if rho depend on time? To answer this question, first we must define the electric current concept related to J vector here, which the first derivative of charged particle here with direction J hat, and the next one is electric current again but with density, which I denote J capital here relate to J over A about density in one direction. So here J vector I can define is equals to lambda multiplied by V vector, which this lambda is about charge over length. So for many particles, and then we can generalize to continuous system, J vector is equals to this summation, which I is index about particle 1, particle 2, and so on, which in continuous system we can generalize as this integral along omega region. This integral we can replace as this blue, and notice that in this red, we recall the Q is equals to this integral, and this integral we can replace as this, which relate to charge over length here. So then by some replacement and this relation between J and J capital, we will have the equality for integral as this, which again consistent between these two. In 1820, Hans Ørsted find out that if we have wire with electric current density as J capital, then it will generate some kind of field that act like force, let's say here pattern as B in later formulations. Because of this kind of field, it make the dust or some kind metal grain create some cylindrical symmetric pattern like this. This result inspired Ampere later to analyze this phenomenon, which then we know about B vector field here as magnetic field, which this come from magnetism in ancient time. And we back to set of experiment. In this, we take two loop here. One is nearest and the other one is further. Then the nearest here will be neat, and the further here will messy, that create a pattern that too far from source, then formulate in mathematics by Ampere law as vector field B proportional to J capital vector over inverse squared law as in Coulomb law. So then this proportional will become this equality along this wire as yellow, which this J related to xi and xi prime, because the prime come from this integration, so here is prime, and then the result as magnetic field here relate to vector field along xi. And by previous video, this pattern create loop of magnetic field, which J capital here relate to source of the rotation. So by intuition, using Stokes theorem, we get that nabla cross B here proportional to J capital, and because of this mu0 to this J capital source, then the equality of nabla cross B will equals to this, which this result known as Ampere law in differential form. These equations tell us that if we want to generate a magnet, then we need moving charge. So here, magnetic field is totally loop as vector field. So here, if we take nabla dot B, then it will equals to 0. Or if we have a region here, and inside the region we have natural magnet with the pole as north and south as a charge movement in natural magnet, then the magnetic field will become this, which let's say the out and in of the magnetic field to the region in total equals to 0. And this is why by divergence theorem, nabla dot P is equals to 0. This result, known as no magnetic monopole law or Gauss law for magnetism, which usually we denote as no magnetic monopole law, and by this law, even if we have accelerated magnet here, then it still can create a monopole. So, the monopole in electromagnetism only in electric field, as we know as electric charge. And fun fact, this mu0 is about magnetic permeability and 0 denote to vacuum. So mu here is medium response in analog to epsilon before as permittivity. So magnetic permeability relates to response of medium to magnetic field. And finally, if we summary all equation we know, we can divide two parts as stay universal part and then acceleration is equals to 0 charge. Which here in stay universal part, we have nabla dot A is equals to rho over epsilon 0 and then nabla dot P is equals to 0. And for non-accelerated charge here, we have nabla cross E is equals to 0 vector. And then nabla cross P is equals to mu0 multiplied by J capital. And that's why this video relates to magnetostatic field. The question is, what for generally non-zero acceleration vector? This will be our discussion in next videos. And that's how we derive about magnetostatic field. I hope you enjoy this video. If you like this video, don't forget to share and subscribe. If you have any question, drop comment below. Thank you and see you later.